Welcome students. In this lecture, I'll discuss about the solution, that is the solution of the auxiliary equation of the form like this: f of d y equal to 0, okay, and d is the operator like d dx, okay. So now as you know from your last lecture that we are discussing about linear differential equation with constant coefficient, okay, exactly higher than 1. So suppose a differential equation is given which is first order. So first order means dy dx, so it has only one root. Suppose that root is m1, okay, that root is real and that root is m1. So how we write the solution? We will write the solution like c1 e to the power m1x, okay. From our last lecture we know that the complementary function involves arbitrary constant, and that is here c1 for one constant, for two constants c1 c2, for three constants c1 c2 c3, like this, okay. So if suppose a first order differential equation has only one root, that root is m1, then we are writing the solution like c1 e to the power m1x, right. Suppose a second order differential equation we are considering. So second order means d2y dx2, so it has two roots, and these two roots are real and distinct, say m1 and m2. Then for distinct root we are writing like c1 e power m1x plus c2 e power m2x, okay. And suppose we have a third order differential equation which has three roots, m1, m2, m3, and these three roots are real and different. So how we write the solution? c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x, right. Now see, if a second order differential equation has two roots and these two roots are real and equal, these two roots are real and equal, say m1 and m1, then how we write the solution? c1 plus c2x whole of e power m1x, okay, c1 plus c2x whole of e power mx, okay. And suppose a third order differential equation has real and equal roots, okay, all the roots are equal, suppose 1 1 1 or minus 1 minus 1 minus 1, so m1 m1 m1. So how we write the solution? c1 plus c2x plus c3x square multiplied by e power m1x, right. So suppose you know that complex roots occur in conjugates in pair, okay, from complex analysis you know that. So suppose one pair of complex roots occur, okay, alpha plus minus I beta, then how we write the solution? Okay, the real part we are writing e power alpha x, okay. For real part, suppose the roots are 1 plus minus 2y, 1 plus minus 2y. So how we write that? E power 1x into c1 cos 2x plus c2 sin 2x, okay. Okay, that means if the roots occur like alpha plus minus I beta, then how we represent the root solution? E power alpha x into c1 cos beta x plus c2 sin beta x. Or we may write like this: c1 e to the power alpha x cos of beta x plus c2, okay, or c1 e to the power alpha x sin of beta x plus c2, okay. And if two pair of complex and equal roots occur, okay, two pairs of complex and equal roots occur, so that means this is one pair, alpha plus minus I beta, and the same roots occur again, alpha plus minus I beta, okay. So how we represent the roots? So this is a combination of these things, that is e power alpha x, you have to write, and for complex part, because we have to write like c1 plus c2x cos beta x plus c3 plus c4x of sin beta x, okay. And if one pair of third roots occur, that is alpha plus minus root beta, then how we write here? Here will be cos hyperbolic function. Already I discussed about the hyperbolic function. So how we write the solutions? E power alpha x c1 cos hyperbolic root beta x plus c2 sin hyperbolic root beta x, right. or in other form like c1 e power alpha x cos hyperbolic x root beta plus c2. Here also you just see that since we have two pairs of root, we have one pair of root, that means we have two roots, so there is two arbitrary constant, one is c1, one is c2. Okay, so yeah, so if we have two pairs of surd but equal roots, that is alpha plus minus root beta and alpha plus minus root beta, how we write the solution? It can be written as like e power alpha x c1 plus c2x cos hyperbolic root beta x plus c3 plus c4x sin hyperbolic root beta x, right? Okay, so you will be better understood if I provide you some problem. So this is one problem, we need to solve this differential equation. So here you see that right hand side is 0, right hand side is 0. So here the solution of complementary function give you the solution of general, solution, right? From our last lecture we know that if you have differential equation of the form f of dy equal to some x, then it has two solutions, one is complementary function, one is particular function, and the general solution is like complementary function plus particular integral. Okay, since the right hand side is 0, so we have only the complementary function. Okay, and that will give you the general solution. Okay, so here they reduce some steps, so I am doing so. Just see here, solve this differential equation, okay, equal to 0. So in d form, if we write d approximately ddx, so we can write here like d3 plus 6d square plus 11d plus 6d plus 6 whole of y equal to 0. So its auxiliary equation of 1 is d3 d cube plus 6d square plus 11d plus 6 equal to 0. Now here you need to do some algebraic calculation. Obviously the algebraic calculation that this you can consider as an algebraic equation, and this is a cubic equation, and you know that by zero method we can solve it. So zero method means what? This is like f of d equal to d cube plus 6d square plus 11d plus 6. So if we put d equal to minus 1, then f of minus 1 equal to 0. That means f of minus 1 is 0. That means what? For d equal to 1, we get left hand side of 2 is 0. That means d plus 1 is a factor of 2. So how many factors of the cubic equation? It has 3 factors. So then you write this portion, okay. Then you just conclude about this line, okay. So first you do 3, you get d plus 1 as a factor, no? So you just write 3 factors, d plus 1, d plus 1, d plus 1, okay. So if you multiply d by d square, then you get d cube, right? So multiplied by d square, so what you get? D cube plus d square. So how many d square is there? 6d square, no? You need extra 5d square, so write down plus 5d square, and then again d plus 1 is there, okay. So you need to multiply d by 5d to get 5d square, okay, multiplied by 5d. You get 5d square and plus 5d. Now here is 11d, so I need another 6d, right, to get 11d, okay, I got it, here 6d. So now what to multiply with d, so that to get 6d multiplied by 6, right? So 6 multiplied by 6 here, 6d plus 6, okay. So you just remember this step carefully, okay. Now what we get? D plus 1 into d square plus 5d plus 6 equal to 0, right? Now the cubic equation converted into two multiplication. One is one pair and another is quadratic equation. Now solve this by middle term method. So you know that here is plus, here is plus, so middle can be found by adding. So 3 into 6, so 3 plus 2, yeah, 5. So d square plus 3d plus 2d equal to plus 6 equal to 0. So if you take d common from this 2, so you get d of d plus 3. If you take 2 common, then you get plus 2 d plus 3. So ultimately you got d plus 2 and d plus 3 equal to 0. So what are the solutions? D equal to minus 1, minus 2, minus 3. Now you see all the values are different, all the values are distinct. So if all the values are distinct, how we write the solution? C1 e power m1x means e power minus x plus C2 e power minus 2x plus C3 e power minus 3x, because all the values are distinct, okay, where C1, C2, C3 are arbitrary constant. So that is your required general solution, okay. So required general solution is C1 e power minus x plus C2 e power minus 2x plus C3 e power minus 3x, okay. Now do another problem. Here is quadratic equation, no, this is quintuple equation, okay, that is fourth degree equation. So how to solve the fourth degree equation? Remember, if 4, 3, 2, 1, then constant term is there, then definitely there will be a there by putting some value we get a left hand side 0, okay. So you need to check for what value the left hand side is 0, okay. So I found that if we put d equal to minus 1 in 2, we get 0 in the LHS. That means d plus 1 is a factor. So factor means what? If that means quotient is 0, na? Remainder is 0. Factor means remainder is 0. So just divide divide this polynomial d power 4 minus d cube minus 9d square minus 11d minus 4 by d plus 1. What you get? See, here is how you divide. How two polynomial can be divided, you have to know, okay. For that you will see that if we divide d power 4 by d, what you get? D cube, right? So write here d cube. So what you get? D power multiply, now d cube will be multiplied through the term, okay. So d power 4 plus d cube. Now subtract, this will cancel out, this will be minus 2d cube minus 9d square. Now here is d, so what you multiply? Minus 2d square to get minus 2d cube, right? So minus 2d square into whole this, so minus 2d cube minus 2d square, right? So now subtract, this will be cancel out, this will be minus 7d square and taking here minus 11d. Now you just multiplied by minus 7d, right? Minus 7d, what you get? Minus 7d square minus 7d, right? Subtract, you get minus 4d, taking minus 4 here, so you need to multiply by minus 4 to get cancel out here, you get remainder 0. Now this term can be written as what? You know that dividend equal to divisor into quotient plus remainder. So dividend is equal to divisor into quotient, remainder is 0. That means this term can be written as d plus 1 into multiply this, okay. Now this is the cubic equation, and here all the time 3, 2, 1 constant is there. Now again you need to put some value so that it gets 0 in the so if I put d equal to minus 1, then we get 0. That means d plus 1 is a root, okay. So d plus 1, d plus 1, d plus 1. Now here is d cube, so multiplied by d square, so you get d cube plus d square. Then here is minus 2d square, so you need to subtract minus 3d square. Then you need to multiply by minus 3d, so minus 3d square minus 3d. Here is minus 7d, so minus 4d, so minus 4 of this you get this. So d plus 1 into d square minus 3d minus 4, okay. Now this is very simple. So just multiply this. This is the quadratic equation. 4d minus 4d plus d will get this value. So just by this way you get 4 minus 3 minus 1 minus 1 minus 1. Now what is the general solution? C1 for 4x, because only one root is unequal and all the 3 roots are equal. For unequal root we write C1 e power 4x. For equal roots we have to write C2 plus C3x plus C3x square whole into e power minus x, right? Because there are 3 roots, okay. C1, C2, C3x, C3x square whole into e power minus x, okay. In our next lecture we will do some more problem, okay. So thank you all.